Good morning Year 9, hope you're all well. Welcome to today's maths lesson. Let's start off with a quick starter as we usually do. On the board are a few maths questions. Please pause the video for 5 to 10 minutes and in your rough books or on your mini whiteboards, whatever you have to hand, have a go at these questions for me. There's a multiplication, a simplification using index laws. Can you find the nth term of this sequence? What's the lowest common multiple of 3 and 6? Can you factorise 4x squared subtract 9? If 17.2 has been rounded to one decimal place, can you write the error interval? And there's an extension question from a GCSE paper at the bottom to have a go at if you're feeling more confident. So pause the video for 5 minutes and have a go at these questions now. Rightio, let's go through the answers. Now the first one, if you've done that multiplication, you'll have got 2,160. Simplifying this term is going to give you 3 to the power of 10 because our rule is we subtract the powers when we're dividing. So 3 to the power 10. Finding the nth term, the number in front of n is the difference between the terms. In this case, the terms have a difference of 3. So we know it's going to be 3n plus something, and it's going to give us 3n plus 1, because to go from the 3's times table, we need to add 1 to get this sequence. Finding the lowest common multiple of both 3 and 6, that's going to be 6, because 6 is a multiple of both 3 and 6, and that's the lowest one. If I factorise 4x squared subtract 9, that's 2x plus 3, and 2x subtract 3. This is a difference of 2 squares. 4x squared is just 2x squared, and 9 can be written as 3 squared. So this is an example of our dots, our difference of 2 squares, and to factorise it we have 2x plus 3 and 2x subtract 3. If I need to write the error interval for 17.2, that's going to look like 17.15 is less than or equal to x, because 17.15 will round up to 17.2, but x is also less than 17.25, but we can't include 17.25 because that would round up to 17.3. If you had to go at my extension question, you'd have got 511. 7 times 73, or 7 is a factor, or 73 is a factor. Either of those would be a good reason to prove that 2 to the power 9 subtract 1 is not a Mersenne prime. Okay, we're going to go through the diagnostic quiz. So A, B, C or D for these 5 questions, and then I'll go through the answers at the end. If you need a little bit of extra time at any point, you're welcome to pause the video. So question number 1. Which of the following is not a possible method for calculating the volume of this cuboid? Question number 2. Joe needs 3 litres of milk. How many of these cartons will he need to buy? He needs 3 litres of milk. How many of these cartons is he going to need to buy? Question number 3. A company sells pencils in packs of 6. These are sent in a box with the dimensions 30 centimetres by 40 centimetres by 30 centimetres. How many packs of pencils will fit into the box? Question number 4 for me. This is a nice one. What's the volume of this cube? What is the volume of this cube? And finally, question number 5. A prism has a volume of 100 centimetres cubed and a length of 4 centimetres. What is the area of its cross section? So some kind of prism has a volume of 100 centimetres cubed. We don't know what type of prism, but we do know it's got a length of 4 centimetres. What is the area of its cross section? Okay, I'm going to run through the answers to those questions. Question number 1. The method that's not used to calculate the volume of this cuboid is A. We can't just multiply together all of those lengths, so A is the incorrect answer. For question number 2, you're going to need 4 of these cartons to obtain 3 litres of milk. 8 times 8 times 15 is going to give me 960. So I've got 960 millilitres in 1 carton. So to get 3 litres, I need 4 of them altogether. Question number 3, the correct answer was D. Question number 4, the volume of this cube is 5 times 5 times 5, and that gives me 125. And for question number 5, a prism has a volume of 100 centimetres cube and a length of 4 centimetres. Now the volume of the prism is given by the cross-sectional area A times the length. No matter what type of prism we have, the volume is always the area times the length. So to work out the cross-sectional area, I need to do the volume divided by the length, which in this case is 100 divided by 4, which tells me the cross-sectional area is 25. Okay, a quick recap. We've done lots of practice on this. Multiplication with surds, and we said the square root of A times the square root of B was the square root of A times B. We can put those together. For a couple of examples, for the first one, I can say 3 lots of the square root of 3 times the square root of 3 is the same as 3 lots of the square root of 3 times 3, which is 3 lots of the square root of 9, the square root of 9 being 3. That tells me that's 3 times 3, which is 9. For the next one, I can approach it in the same way. This time I've got 3 lots of the square root of 3 times 2, which is 3 lots of the square root of 6. This time there's no square number that's a factor of 6, so this is our fully simplified version for this example. But what happens if we're dividing with surds? We're going to need a new rule. I've got the square root of 54 divided by the square root of 3. I know, using my rule of surds, that I can split that square root of 54 up into 2 surds. So I can split the square root of 54 into the square root of 3 multiplied by the square root of 18. I've split up 54 into 2 factors, the square root of 3 and the square root of 18. That's still over the square root of 3. I can now cancel out. I can cancel out that top square root of 3 and the bottom one by dividing top and bottom by the square root of 3. And that leaves me with the square root of 18, which I could then choose to simplify. I can write that as the square root of 9 times the square root of 2, which gives me 3 lots of the square root of 2. Now the square root of 18 I could have found a little bit quicker, because the rule for dividing with surds is the square root of one number over the square root of the other is actually equal to the square root of the first number divided by the second. So I can quickly skip to the square root of 18, and that's our new rule. So dark blue book's out for me. Can you give me the title Dividing Surds and the dates? And then underneath, can you write this rule? The square root of a surd A divided by the square root of a surd B is equal to the square root of A divided by B. And when you've got that down, I'll go through 2 examples, and then there's going to be 2 for you to do. Here's my first example. I've got the square root of 12 divided by the square root of 3. I'm going to write that using my rule as the square root of 12 over 3. 12 divided by 3 is 4, so that's just the square root of 4, which gives me 2. For my second example, I'm going to write that as the square root of 44 divided by 4. 44 divided by 4 just gives me 11. So that's the square root of 11. Over to you guys in your dark blue books. Please pause the video for a minute or two and have a go at these questions. Okay, I'm going to go through the answers with you. The first one, I can write that as the square root of 24 divided by 6. 24 divided by 6 is 4, so I write that as the square root of 4, which just as before is equal to 2. We might have been able to predict that from our previous answer because I've just multiplied 12 by 2 to get 24, and I've multiplied 3 by 2 to get 6. I've multiplied top and bottom of that fraction by 2, therefore I get the same answer. For the second question, I'm going to write that as the square root of 48 over 4, which is the square root of 12. I can simplify that. I can say the square root of 12 is equal to the square root of 4 times the square root of 3, because 4 times 3 gives me 12. The square root of 4 is 2, so I can write that as 2 square root 3. Please make sure you've got some of these examples in your dark blue books. Over to you guys in your light blue books. Please have a go at this question for me. Can you simplify fully the square root of 48 over the square root of 12? Pause the video if you need. Okie dokie, I'm going to go through the answer. Using my rule of surds, I can write this as the square root of 48 over 12. 48 divided by 12 just gives me 4, so I can write that as the square root of 4. And the square root of 4 we know is 2, so the correct answer is D. In your light blue books, can you please pause the video for 10 to 15 minutes and have a go at these questions for me, using your rule of surds that I've put in the top corner for you to help you out. Pause the video now. And the answers are up on the board. Please check your work and see how you did. Okay, we've done lots of work on surds, and I've summarised the main rules we've come across so far on the board now. The first one, we said, well, if I'm multiplying surds, the square root of one surd A times the square root of a second surd B is equal to the square root of A times B. For example, if I've got the square root of 2 times the square root of 8, that's going to be equal to the square root of 2 times 8. 2 times 8 is 16, so that's equal to the square root of 16, which is 4. Now we used this rule backwards to simplify surds. We said, well, if the square root of A times B can be written as the square root of A times the square root of B, we can write surds more simply by finding the largest number that's a square number and a factor of the number under the square root sign. For example, 5 square root 40, I could write as 5 times the square root of 4, because 4 is a square number, times the square root of 10. I've split up 40 into its two factors, 4 and 10, and found the largest number that's a square number and a factor of it. 5 times the square root of 4 is just 5 times 2, which then gives me 10. So I've got 10 lots of the square root of 10. We then looked at division. I said, well, the square root of A divided by the square root of B is equal to the square root of A divided by B. For example, if I was working out the square root of 8 divided by the square root of 2, I could write that as the square root of 8 over 2. 8 divided by 2 gives me 4. So that's the square root of 4, which is 2. And lastly, we also looked at addition and subtraction of surds, and we said these worked in the same way as algebra. If I've got some number of the square root of A, and I add on another number of the square root of A, that's going to be equal to some number m plus some number n lots of the square root of A. For example, if I was working out the square root of 32 plus 3 square root 8, I would start by simplifying this first surd. I can say, well, that's equal to the square root of 4 times the square root of 8 plus 3 lots of the square root of 8. The square root of 4 is 2, so I can write that as 2 lots of the square root of 8 plus 3 lots of the square root of 8. I've got 2 lots of the square root of 8 plus 3 lots of the square root of 8, so altogether I've got 5 lots of the square root of 8. But that's not fully simplified because there's a square number that's a factor of 8, and that's 4. So I can write that as 5 times the square root of 4 times the square root of 2, splitting 8 into its 2 factors. The square root of 4 is 2, so that gives me 5 times 2, which is 10 lots of the square root of 2. Over to you guys. Please pause the video for 5 minutes and have a go at this code breaker for me. Simplify the surds at the bottom using the laws we've just been through and find your answers in the top code breaker. That's going to give you a letter, and if you arrange the letters in the right order, that will reveal what the mechanic had on their toast. Pause the video now. And the answers are up on the board. I was looking for traffic jam. That was the correct answer. Code breaker number 2. This one's a little bit trickier. Now I've included division and addition. Can you pause the video for 5 to 10 minutes and simplify these surds for me? Link your answers up to the table at the top and see if you can reveal what the forger had on their toast. Pause the video now. And the answer is up on the board. This time I was looking for faked beans. Well done if you got that right. You needed to remember when you were working with addition and subtraction, you needed to simplify those surds first. And if you're feeling super confident, please pause the video for 10 to 15 minutes and have a go at these extension questions for me. These are super tricky. And these are the answers I came up with. Please let me know if I got any of these wrong. I spent a lot of time on this. They were really quite complicated. You had to simplify, multiply and divide all together. And that is the end of today's lesson. Please head on over to Google Classroom and submit today's exit ticket so that I can assess your learning. Have a wonderful day. Thank you very much for listening. Off you go. Goodbye.